A square ABCD is of 5 meters. Forces of 10, 5, 12, 15 Newton act along the sides A, B, B, C, C, D, and D respectively in the direction of the letters in the figure. That's the figure. Find the resultant in magnitude and direction, and where its line of action cuts AB and AD. Now, to find the magnitude is very easy. We just need to get the components along the x and y direction. Let's make this x direction and this y direction. So, to resolve along two perpendicular components and direction. Sorry. Now, let's say resultant is R. Rs. We have 10 minus 12 minus 2 Newton. So it is 2 Newton towards the left. Now let's see Ry. And it is 5 minus 15. And that is minus 10, which is 10 down. 10 Newton downward. Now the resultant R is equal to Rx squared plus Ry squared roots, which is 104, and that is 10.2 Newton. That's 10.2 Newton, the resultants. That's 10.2 Newton. So we now need to find the direction. The direction. So to find the direction, you just need to look at this value. So the direction of the resultant is like this. This one is 2, this is 10. So you can find it to x, you can find it to y. So let's see. We find it to the vertical direction. So this place will be 2 and this place will be 10. So this is our theta. So it will add tan 2 over 10, which is, and that is 11.3 degrees. So it is, so the vertical 11.3 degrees. So you know the horizontal will be 90 minus 11.3 degrees, and that will be like 78.7 degrees. Then we are also asked, we have found the direction and the resultants in magnitude direction. Where is the line of action? To find the line of action, you can do that one in 3 ways. Now let us also find the total moment about A. About this point. Let's find what it is. So it is going to give us 10 times 0 plus 5 times 5. Please remember, the dimension of the square is 5 is 25. This one too is anti-clockwise. It's 12 times 5 plus 15 times 0. You know, this one is directly along this point. So it's not giving us any moment there. So we have 25 plus 60. That's 85 Newton meter. And it is in clockwise direction. So we can see that this resultant will have to act here or here, but we see that the direction is here. So our perpendicular distance from this place, from the line of action of the force, will be x. Therefore, we got 10.2 times x is equal to 85. So x is equal to 85 over 10.2, and that gives me 85 divided by 10.2. 8.333 meters. So you can see this place is 8.33 meters. And now we are asked where it cuts AB and AD. I have known that this place is 11.3 degrees. So since this place is 90, I know that this place is going to be 90 minus 11.3 degrees. So this place too is going to be 11.3 degrees. You can see this place and this place, they are equal. Now, I have known what this place is, 8.33 meters. I want to find this place and I want to find this place. Now, this is opposite to this side. So, AY over X is equal to sine 11.3 degrees. I work that one out. If you look at this, this is adjacent and this is hypotenuse to this angle. So, AX. Okay, let me make this one AF. Now I can now say AF over X is equal to cos 11.3. Yes. Let me now work it out. So this divided by sine 11.3. So this one gives me AY This one is opposite. This one is hypotenuse. So x will be equal to ay sine 11.3. So ay will be equal to x divided by sine 11.3, and that's going to give me 8.33 divided by sine 11.3. That's 42.53 meters. So along this direction, along the horizontal, that is along the AB, I have x to be equal to AF cos 11.3 degrees. So AF is going to be 8.333 over cos 11.3, and that is 8.498 meters, approximately 8.5 meters. So that is one way of getting it. Another way you can use to get it is, we know that these are resultants. R is 10.2. Here this place is 10 and this place is 2. And this place is 11.3. So if we resolve it, you can see that along the horizontal it is 2 Newton. And we just need to divide this moment by these 2 Newton. It will give us the perpendicular along this place. You can see. So AY will be equal to RX times, AY times RX will give us 85 Newton meter. You can see. So the perpendicular distance of the resolved portion of this will be like this. So it's going to give us AY will be equal to 85 divided by 2, which is 42.5. And then AF times RY will be equal to 85. So AF will be equal to 85 divided by 10, which is 8.5 meters. Very straightforward. You can see this one is very fast. Now, since I have known that the moment it will give me anti-clockwise moment and it is in the downward direction like this. So let's make this place F. And let's make this place the distance here. Let's call it M. We have said, when we are finding the moment, we are going to find a place where F will act and give us the moment that will be equal to that one. Now let's take moment about F, just like we did in the explanation in the notes. The moment about this place will be 0, because this one is giving us moment of 0 here, and all these ones too, they will give us the moment 0 here. Are you getting it now? So let's make this n, and let's take all the moments about these points. Let's start this one, 10 times 0, because it's along this place, plus 5 times 5 plus n, you can see, plus 12 times 5, because the perpendicular distance is this, plus 15 times n will be equal to 0, because this f is giving us 0 at this point also. So we have done examples like that in the past. At the end of the day, we are going to have 25. Okay, wait. This one is downward, please. This one is going to give us minus. This one is going to give us minus. This one is positive. This one is downward. So this is 25 plus 5n plus 60 minus 15n. So I can see that 85 minus 10n is equal to 0. So n will be equal to 85 over 10, which is 8.5 meters. Now, at the same time, let me find the point where it cuts this one too. So let me cut it like this. So in the same way, the moment of R about this point will be 0, and all these other forces will give us moment 0 along this place. So let's take moments about y. Therefore, we have this 10 y. Okay, let me make that one n. The distance from here to here, let me make it n. So there will be confusion. 10n, and this one now still anti-clockwise, plus 5 times 5. Yeah. This one is clockwise, minus 12 times y minus 5. I hope you are getting it. This one will give us clockwise moment about the space. This one will not give us anything because its line passes through y plus 15 times 0 is equal to 0. Therefore, call it n now. Sorry. So it will be 10n plus 5 times 5 minus 12 times n minus 5. Because from here to there it will be n minus 5. Plus 15 times 0 gives me 0. Now I have 10n plus 25 minus 12n plus 60 equals 0. So what do I have here? I have minus 2n plus 85 equals 0. So n equals 85 over 2, which is 42.5 meters. You can see, even once I have gotten the 8.5, the relationship tan, I can use it to get the other one. It will be in the ratio of the tangents of the forces. So since I have found the x the other time, I can use this ratio to get the other side. So 8.5 was this place, and so this one will be n. Therefore, n will equal to 10 times 8.5 over 2. And this is 5. And this is 42.5 meters. So, with this, I think I have covered a lot on this system of forces. Locate the center of gravity of the plate in the figure. Now, how do we locate the center of gravity? We will find moments of each part along the x and y direction, and from there, we divide by the total. Let's see. Let's cut into A, B. A, B, and this will be the total. So, area of A, that's for area. Area of A is 4 meters squared. Area of B is 2 meters squared. Let's now look at the center of gravity of each part along x and y direction. Let's look at this x, y, CG. Center of gravity. Along the x direction for A, I have it to be 1 meter from y axis. For B, it's going to be 2 meters plus 1. That is 3 meters. For B, this guy should be 2 plus 1, 3 meters. For the y components of the CG, for A, it is 1 meter. For B, it is going to be 0.5 meter. Now, what is the total area? 6 meters squared. I call this one CX and CY. Now, let's take the moments about Y. Moment about Y over total area. Is equal to CX. You can see, just like what you have been treating, the same way. So, what are you going to have? You are going to have, this one is going to give us 4 times 1 plus 2 times 3 divided by 6. And that's going to give us 10 over 6. 10 over 6. That's 5 over 3. CX is 1. Let me see. Now, CX is 1.67 meters. Now, let's look at that of CY. That is, it's going to be the point where the whole mass will concentrate. Moment about X over total area. And it's going to be 4 times 1 plus 2 times 0.5 over 6. And that gives me 5 over 6. And that is 0.833 meters. So you can see, it's very easy. A three rectangular plate, 5 meters by 3 meters, has a hole 2 meter diameter cut in it, such that the center is 1.5 meters from a short edge. Determine the distance of the mass center from the same edge. So we have something like this. A diagram like this. So this plate is 5 meters. 3 meters, and we are told that the circle, the center is 1.5, and it has diameter of 2 meters. You can see. So to find the CG of this whole diagram, let's make it for the rectangle. You have center, and we have the balance shape. So let's call that one balance shape. Now let's work on the area CG. What is the area of the rectangle? 15. That's 5 times 3. 15. What is the area of the circle? You know the radius is 1. So and the area of the circle is pi r squared. So we have pi. What is the center of this one? For the rectangle, we have this one to be 2.5. We are told that the center of this from this place also is 1.5. 1.5. Now let's work this out. The balance shape is going to have area of 15 minus pi meters squared. And the center, let's call that of CG. So if we take the moments about this place, so if we take the moment about y, moment about y divided by balance area, balance shape area, we are going to have our CG. So what? Please, we have assumed that it is having constant density all through, equal density all through. So we have, so let's take it now. Moment about y, about this place now is going to be 15 times 2.5 plus minus pi times 1.5 divided by 15 minus pi. Let me use my calculator to get the figure. This one is 2.765 meters. 2.765 meters. Determine the position of the centroid of the area in the figure. And this is the figure. So for ease, let's divide the figure into 4 different places. We have A, B, C, and D. Please, we are given hints. Center of triangle is 2/3 of the perpendicular from the apex, and of semicircle is 4r/3 pi from the center. Now we have, this is the horizontal axis and this is the perpendicular axis. So let's work it out by finding the moments about the axis, about the two axes, x and y. Now let's work this out. A, B, C, D, and the total. So we have it like this. So we have area CG along x axis, CG along y axis. So we get this one for each. And let's work this out. For A, the area is half base times height. So this one is 2. This is 1. For this one is 2 times 3. That is 6. For this one is half pi r squared. Half pi r squared. That is half pi 1.5 squared. And then we left it like that. So this will be the total. The sum of all this. Let me call that one total. The sum of all this. Now, what is the center of gravity for this one from y? We have seen that it is 2/3 of the perpendicular from the apex. So this will be our apex since we are taking it from this place to this base. Because if you do it otherwise, it will scatter your calculation. So we have 2/3 times 2, which is 4/3. For this one B, it is going to be 2/3 times 1 plus 2. So you have 2 plus 2/3. Now, let us find the distance of the CG for each axis. We are taking the moment about the axis. For A, the distance of the CG along this direction is going to be 2/3 of this from this place. So this will be 2/3 times 2. That's going to be 4/3 in meters. For this one now, we are going to take this place to this place, which is 1/3 plus this 2, and that's going to give us 7/3. For this one now, it's going to give us 1.5 because this place to this place, if you add it, is 3. So you have 1.5. Same here, 1.5. So let's call this one CX for the whole figure. Now for this, because from here, the distance of the center for this shape is 1. So we have it here, 1. For this 1, A for A will be 2 plus 1 over 3 times 2. Please get it. This distance plus, because from here to the center here is going to be 1 over 3, since it is 2 over 3 from here. So we have 2 plus 1 over 3 times 2. 2 plus 1 over 3, this place. 2 plus 1 over 3 times 2. And that's going to give us 8 over 3. 8 over 3. This one too is the same thing. 8 over 3. For this one, we have the formula here. That is 4 times 1.5. 6 over 3 pi. You can see. Now let's take the moments to find the center for the whole figure. But please note, this is going to be minus. This is going to be minus because it is below the x-axis. Let's take the moments. Moments about axis over total mass will give us center for x and y. Now let's take moment about x. Cx. Okay, let's call this one cy. Will be equal to 2 times 4 over 3 plus 1 times 7 over 3 plus 6 times 1.5 plus 5 times 1.5 squared times 1.5 over 2. Let's use this to divide the total. 2 plus 1 plus 6 plus 1.5 square pi over 2. Let me work that with my calculator. So my answer is 1.54 meters. That is, the center will be from this place 1.54 around this place. Now let's find it along this direction. Now let's find cy. So we have moment about x-axis now will be 2 times 8 over 3 plus 1 times 8 over 3 plus 6 times 1 minus half or pi over 2 times 1.5 squared times 6 over 3 pi. So that's why I get it. Over the total, that is 2 plus 1 plus 6 plus pi over 2 times 1.5 squared. So to find cy now, the moment about x over the total area. So the moment, because this one is negative, you've seen it here, that is minus in this instance. So over the total gives 0.9374. 0.9374 meters. So we have gotten the centroid. So we have a diagram here, and we have to locate the center of gravity of the body. So for it, we are going to divide into two, A and B. So we work with their volume. So we have the mindset that they have equal density because it's the same material. So let's say A, B. This is the volume for A. Volume, sorry, total. So we are going to have something like this. So this will be okay. This is okay. C, center of gravity in the x-axis, center of gravity in the y-axis, center of gravity in the z-axis. So this one is not necessary. So why work it like this? What will be the volume for A? 1.5 times 1.5 times 2. That's 3 times 1.5. That is 4.5. So you can multiply by density if you like. Now for B, we have the volume to be 3 times 1 times 1. So that is 3 meter cube. And you can easily get this total as 7.5. Now, for the center of gravity along the x-axis, for A, it will be 1. For B, it will be 2 plus 1.5. You can see the center of gravity of this one is 1.5 from this joining. So it will be 2 plus 1.5, that's 3.5. Let's check that of Y. For Y, it is 1.5 over 2. Let me just write it like that, please. 1.5 over 2 or 0.75. But I like writing it like this. 1.5 over 2. For this one now, it's going to be, we have it 1 here. So from here to this place is 0.5. So 0.5, and this one is 0.5 again. So we are going to have 1. We are going to have 1 because 0.5 plus 0.5, that gives us 1. Another one is for the z axis. If you look at it, it's the same thing. From here to here now is 0.75 or 1.5 over 2. This is a meter. And this one is meter cube. Again, from this place, because we have seen that this is 1. So from this place to this place is 0.5. Plus the center here is 0.5. So this one too is 1. You can see. So we are going to find this center. This center. How do we do that? We take the moment and then we divide by the total volume. Let's do that for x. So Cx is equal to 4.5 times 1 plus 3 times 3.5 over 7.5. So let me work that out straight. This is 15 over 7.5. That is 2 meters. So along the x-axis is 2 meters. For the y, we are going to have it like 4.5 times 1.5 over 2 plus 3.5 times 1 over 7.5. So let's work this out. So Cy is 4.5 times 1.5 over 2 plus 3 times 1. That is the area times the distance. And that's going to give us giving us 0. So working them out, 0.8 times 0.85, this one is 2 meters. Very easy and straightforward. The box has a base 0.2 meter by 0.4 meter, and the side 0.5 meters high is made of thin steel sheets. The bottom being reinforced by having double thickness. Find the distance of the center of gravity above the base when the tip is off the box. So we have let us call the thickness C. Let's call the thickness C. And we work with volume. Now we have something like this. So 0.2, 0.4. And it's doubled again. You can see. So we have that one doubled, but the height is the height is 0.5. So let us find the volume of the material used. But let's say, okay, let's give it density. So we can find the mass, we can work having the mass. So M will be the volume for base will be equal to 0.4 times 0.2 times T. Please note, you are told that it is double times 2. For the sides, volume for side is equal to 0.5 times this place 0.2 plus 0.5 times 0.4 times 2. See, this side and this side. So everything gives me this. So at the end of the day, total volume will be equal to this is, let me work it out. So we have 0.76 T. So mass total will be 0.76 T times density. Now let's take moments about the base. Moments about the base and over total mass. That will give us the center of gravity from base. And let's do that. It will be the mass of the side times the center, and that will be 0.25. And what is that? It's going to be this one times density times 0.25. So 0.25 times this is 0.6, 0.5 times 2 times 0.6 divided by 0.76. And what does that give us? So the answer is 0.1974 meters. So you can see this is not a solid box, solid block. This is a box with space inside, and that's why we devised this method of working it out. A wire frame is in the form of a triangle ABC with AB equal to BC, B equal to 0.1 meters, and C equal to 0.15 meters. If it is on from the point A, determine the angle that AB makes with the vertical. What we are saying is this: a frame, just like wire, we have it like this, and we are told that AB equals to BC, ABC, and CA or AC 0.15 meters. This one is 0.1 meters. 0.1 meters. And we are asked that if this one is now placed like this, what will be the angle between AB and the vertical? Let's work it out. We can see that we have a situation of isosceles triangle here. So our work is a bit easy. And because of that, we can easily cut this into A. Let's make it like this. So if we make this one the horizontal, the vertical. Along the horizontal, there's no point there. We don't need to busy ourselves. This is where the CD will be. So CX will be 0.15 over 2, 0.075 meters from A here. Now let's look at what will it be on the Y. The same way we have been treating all these other ones. This one will be at the middle here. This one will be at the middle here. And this one will be at the middle here. Now, the moment about this place now. Yes, the moment about x direction now. That's going to give us our CY. Let's look at this. This place is 0.75. So we are going to use our proportion easily now. 0.75. And if you look at this place now, we can use our Pythagoras theorem to get this place. This place will be, let's call this one D. dB is equal to square root of 0.1 square minus 0. Oh, this one is 0.07, please. 0.075 square. And what does that give us? So this gives 0.06614 meters. Automatically, this one is acting from this place, that is 0.5 here, 0.5 here. The same thing here, 0.5 here, 0.5 here. Now, let's agree that the density per unit length is constant. Density per unit length is constant. Therefore, the moment of this area about this place, we are going to take it. So let's call this one A, let's call this one B, and let's call this one C. So, for A, B, and C, length y, cy. This one is 0.1. This one too is 0.1. And this one too is 0.15. And then we have the total there. You get it. 0.35. Fine. So this is our CG, CGY. In this place, if 1 will make it 0.0614. So 0.5 will make it 0.03307. So this is 0.03307. Same thing here. 0.03307. 0.03307. And this one is 0. You can see it's along this line. Now for us to now find this place now, we are going to make it like this. Moment about AX over total length. What does that give us? 0.1 times 0.03307 plus 0.1 times 0.03307 plus 0.15 times 0. All will divide by 0.35. So what is that going to give us? So you are going to have it here from this base 0.0189. 0.0189. Let us now look at something. The angle here, the total angle here is going to be arctan this place over this place. So let's call this place theta. So theta is arctan. Oh, I don't need to use tan. since I know this one and this one, theta is equal to r cos 0.075 over 0.1. So that gives me, so you can see it's 41.41 degrees. Now, from this place, for a line that passes through the center of gravity, the angle is to make here, let's call that one alpha. So alpha is equal to, I know this place and I know this place, r tan 0.0189 over 0.075. Please, this is the triangle I'm considering. Let's make it AED. Triangle AED. Triangle AED. Please, note. So for triangle AED, this is the ED. So alpha is equal to 14.14 degrees. You can see now. So which means that if I should leave it and it comes down, I'm going to have something like this. A, B, and C. So it's going to be like this. If you look at it, AC, the angle from A to C, the portion is 14.14 degrees. So this portion that you make, that AB made with the vertical, inclination of AB to the vertical will be equal to 41.41 minus 14.14, and that will be 27.27 degrees. So you can see how it works out. Very easy and straightforward. A square ABCD is of 5 meters. Forces of 10, 5, 12, 15 Newton act along the sides AB, BC, CD, and DA respectively, in the direction of the letters in the figure. Here, this figure. Find the resultants in magnitude and direction, and where its line of action cuts AB and AD. Now we have our square, and the dimension is 5 by 5. For us to find the resultants, let us find the horizontal and vertical for resultants. Let's say R is the resultant, and let's make this X and this place Y. So Rx is equal to 10 minus 12, which is minus 2 Newton. That is, its resultant is 2 towards this direction. 2 Newton towards this direction. Ry, we have 5 minus 15, which is minus 10 Newton, which means it is in this direction. Therefore, our R is in this direction. You can see our R is in this direction. So we have something like this. This is our R. So let's see what the, and this is the direction to the vertical. This is the inclination. So we can find this place. This will be, this is 2 and this is 10. So we can also make this one 2, 10. So to find our theta, in this instance, theta is equal to r tan 2 over 10. R tan 0.2. And what is that giving us? That is 11.4 degrees. 11.4 degrees. We also have another question. It says, so this is how it goes. It says, where is the line of action, and where is line of action cuts AB and AD? I will show you like 3 ways you can get that. Sorry, R, the value of R, magnitude of R is equal to square root of 2 squared plus 10 squared. Square root 104. And that is 10.2 Newton. So that is the direction for the, that is the direction. And if you look at it, it will be like this. 90 minus 11, that is 79, let's call it 78.6 degrees. So like this, hey, sorry. like this. So it is going to be 180 or 270 minus 11.4. So we have it. This is 258.6 degrees. So it will come towards this direction in the third quadrant. Now we are asked to find the line of action. Here it calls A and AB and AD. Yes. Let's find the total moments, clockwise and anti-clockwise, so that we know the place where it tends to rotate to. We have it like this. About A. Let's find the moment about A. Moment about A. So this one will be 10 times 0 plus 5 times 5 times 5, and this one plus 12 times 5 plus 15 times 0. You can see they don't have any movement, that's 0. So it's equal to, what do we have? 25 plus 6. So we have 85 Newton meter in the anti-clockwise direction. 85 Newton meter in the anti-clockwise direction. We also note that if this one is acting in this direction, so the perpendicular distance of this one from this place, you know, we have seen the direction it is acting from, will be, so this is 10.2, and from here this will be the, with this line of action. So let's call this place x. So we have x. Therefore, x times 10.2, because it is acting down like this, you can see, will be equal to 85. X is equal to 85 over 10.2. And what does that give us? Is equal to 25 over 3, which is 8.33 meters. With this, we have gotten something initially, that this place is 11.4 degrees. This place to here will be 11.4 degrees. So we can easily get the intersection at y and the intersection at x. You can see here. So let's find y. This is opposite to this place now, and this is the hypotenuse. So x, that is 25 over 3, that is the opposite, is equal to ay sine 11.4 degrees. Therefore, ay is equal to x over sine 11.4, which is 25 over 3 times sine 11.4. Let's see what that will give us. ABC is a uniform rod of mass 8 kg and length 3.5 meters. AB and BC form two sides of a right angle triangle. AB equals 1.5 meter. What is the least force applied at C, which will maintain the rod in equilibrium when suspended freely from A, so that BC is vertical? So what we have is this: A, B, C. A, B, C. And we are told that AB is 1.5, BC is 2 meters. Then, because the whole length is 3.5. And we are told that it forms two sides of a right angle triangle. AB is 1.5. What is the least force applied at C? So which means that the generator turned it like this. AB. And this one now from down like this. C. A. So this one is 1.5, therefore this one is 2 meters. We are now asked, what is the least force that will make this one vertical? The least force that will make it vertical will be a force that is perpendicular to this distance here. To this distance. And let's call this force P. Let's call it P. What? And we have been told that the mass of this rod is 8 kg. Therefore, 3.5 weighs 8 kg. Then 1.5 weighs 1.5 times 8 over 3.5. 2 meter weighs 2 times 8 over 3.5 kg. And you have been told that G equals 9.8 meters per second square. So we multiply this one by 9.81. This one too by 9.81. So we have it in Newton now. We have it in Newton there. So this one, the weight here will pass through this place. And it is 0.75 here. 0.75 from here. Because it is 1.5. This one will pass at 2. And this one is this weight here. Let's call this one weight A, weight B. So weight B will act here, weight A will act here. And this one will counterbalance the weight moving upward. So let's see what it will be. So P, what the distance from here to here is going to be, using Pythagoras, this is 2, this is 1.5, so this place will be 2.5. Ratio 3, 4, 5. Therefore, AP, okay, for clarity now, you can see that 8 kg is for 3.5 meters. Therefore, this 1.5 meters here, 1.5 meters, we weigh 1.5 over 3.5 times 8 kg. This one here will make 2 meters. We weigh 2 over 3.5 times 8 kg. And we know that our G, acceleration due to gravity, is 9.8. Therefore, the middle of this one is 0.75 from A. And that is where the weight of this one will act. So let's call this one WA. Let's call this one WB. So WA will act here, 0.75 from A. That's WA. WB will act here. And that is 1.5 meters from A, perpendicular distance. And we know that the distance of this place to C is 2.5 from our triangle, right angle triangle relationship, 3, 4, 5. Then, we use Pythagoras rule, we get this one. So P, this will be the clockwise moment, and this one are, okay, this is anti-clockwise moment, this is clockwise moment. So clockwise, for equilibrium, clockwise moment will equal to anti-clockwise moment. So for clockwise moments, we have 0.75 times WA plus 1.5 times WB is equal to P times 2.5, because we are trying to get the least force, and we can get our WA by multiplying this with G, acceleration due to gravity. So let's make it weight. Therefore, 0.75 into 12 over 3.5, 12 over 3.5 G plus 1.5 times 16G over 3.5 is equal to 2.5 P. So P, if you look at this one is going to give me 1.5 times 6, 1.5 times 16. So this is going to be 1.5 into 6 plus 16 over 3.5 G is equal to 2.5 P. So P, the force will be 50. Now, so P is 1.5 times 22 times 9.8 divided by 3.5 times 2.5. So that gives me 36.96 Newton. That's the force P required. Approximately 37 Newton. Now, assuming the calculator requires us to find the center of gravity, that is the center at which the force will pass through. So we can find this Cy and Cx. So we can find this place, the distance from here and the distance from this point. We can find it. How do we do that? We take moment about the space for the x, and we take moment about the space for the Cy. So this one we ask through the space. And if you look at it, that's 12 over 3.5. 12 over 3.5 Newton. So that is from this place. And this one now is 16 g over 3.5. Now, let's now take moment of this about this axis. So to find CS is the moment about the y-axis. So which is going to be 1 and 0.75 times 12 g over 3.5 plus 1.5 times 16 g over 3.5. So we now divide this with the total weight, and if you add this one and this one, you are going to get 8g. You are going to get 8g. So what are we going to have now? We are going to have 0.75 times 12g plus 1.5 times 16g. 0.75 times 12, that should be like 9. So we have 9g plus 24g over 3.5 times 1 over 8g. So let's cut this, and it's going to give me 33 over 3.5. So this one gives me 1.179 meters along this place. So that is CS. Now let's get CY. That is moment about this place. You can see that this one has no moment about this place, but this one has moment about this place. So CY will be equal to, and this is the center for this one, 1 times 16g over 3.5 over 8g, and that will be 16g over 3.5 times 8g, and the answer will be equal to 0.5714 meters. So the CG for this is 0.14 meters from above, and from this point 1.17 meters from this place. So I'm just showing for plate there's a way you get it, for rod or wire there's a way you get it, and also for volumes there's a way you get all these things. The more you do it, the more fun it becomes. A particle of mass 4.5 kg is projected up an inclined plane of angle theta, where sin theta is 0.2 with speed 2 meters per second. How far will you travel all the inclined plane if the surface is smooth? 2. If the coefficient of friction is 0.6. With this, you can look at it strictly from energy, or you just consider the kinematics, the relationship between the acceleration and velocity. Now let's look at it from energy perspective, that is kinetic and potential energy perspective. Look at this, and we have theta. Your sin theta is 0.2. That is this one. Let's say this one is 1 and this one is 5. We are now told that the body is 0.4 and it's moving from here. 0.4. Okay, yes, it's moving from here. Oh, sorry, it's 4.5 kg. At this point, its energy is what? Ke. It has kinetic energy at this point. Let's get that one. Ke at the base is equal to 4.5. Half 4.5 times 2 squared. So we can get this one now. It's equal to 9 joules. That's the Ke. Now, we can see that it is moving up like this. It has certain restriction, and that is the component of this weight downwards. And what is that? That is 4.5 g sin theta. You can see 4.5 g sin theta. That is the component of this weight down. So this will be a force acting against it. And how much work will it do against this force before it comes to rest? It will be equal to 9G. Now, the components of weight downwards resisting motion is equal to, let's call that one F, is equal to 4.5 times 9.8 times, we are told 0.2. You can see times 9.8 times 0.2. And we know from equation of energy, we know that work is equal to Fs. And it will give us the potential energy, which will be the potential energy. And due to conservation of energy is neither created nor destroyed, but can be converted from one form to the other. This Pe will be equal to Ke before it comes to rest. Therefore, 9 is equal to F times S, which is 4.5 times 9.8 times 0.2 times S. So S will be equal to 9 over 4.5 times 0.2 times 9.8. And if you look at this one is going to give us 0.9. So this one is going to give us 10, which is 10 over 9.8 meters. And that is equal to 1.02 meters. 1.02 meters. So you can see it's very simple and straightforward. You can also look at it from another perspective like this. Since it is going to this height and no other force is resisting it, it will just be like any other. It's just be like any, we talk about closed field. Gravitation field is example of closed field. So it's the same thing as if you take it up. This one is just another avenue to take it to this height. So you can also say that mgh is equal to half mv squared. mgh is equal to half mv squared. So by the time you look at this one cancel this, and you know this one to be 9.8. Therefore, our h will still be 2 squared over 2 times 9.8. And that's going to give me 2 over 9.8 meters. And we have seen that sin theta is 1 over 10. So this place is 2 over 9.8. So this is s. You can see. Therefore, s will be equal to s over 10. Okay, s over 10 or s sin theta will be equal to 2 over 9.8. You get it now? So as I was saying, I have told you that this is the s now. This is the h. So s sin theta is equal to 2 over 9.8. And we are told that sin theta is 0.2. Therefore, s is equal to 2 over 0.2 times 9.8. And that gives me 10 over 9.8, which is 1.02 meters. That's another way to look at it. That is another way to look at it. So, if you consider it from energy, when we look at it strictly from the relationship between velocity and acceleration, I will show you how to go about it now. So, if you understand this, it will assist us in looking at it from several angles. Now, if you look at it, g, in this instance, we will not consider this. Just consider the velocity and acceleration. In this place, v equals to 2 meters per second. And g comes like this. Since it is the same mass, that is it. Because the same mass, the mass is not changing. So g downwards will be g sin theta. You can see. And we know our equation of motion that, and we can now say our u is 2 meters per second. Our final velocity is 0 meters per second. We are trying to get the distance to move along this way. So we know that v square minus u square is equal to v square equals u square plus 2as. You can see. But what is our v square? 0. Our our a is equal to minus g sin theta. You remember, it is acting against the velocity, so it is negative. So we are going to have this one to be equal to 2 squared minus 2 times 9.8 times 0.2. You know, sin theta is 0.2. At the end of the day, you see that 4 equals to, s. 2 times 9.8 times 0.2 s. So s will be equal to 4 over 0.4 times 9.8. Which is, if you call this one, it's going to give you 10 over 9.8, 1.02 meters. So I've shown you three ways of doing this. You can also consider this one just like throwing it up, and that will give you this height at which it will reach. And from there, you get the slant distance mode. So what do I mean? You know, if you throw the object up straight, it's going to be v square equals u square plus 2gh. And our v is 0 square. Our u was 2 square. Our g in this instance is minus. Sorry, it should be minus because the g is acting against the velocity. So it will be 2 times 9.8h. So at the end of the day, h will be equal to 2 square over 2 times 9.8. So we have 2 over 9.8 meters. So and we see that our s sin theta is equal to h. Our s sin theta is equal to h. So we can now see that s is equal to h over sine theta, which is h over 0.2. It's 2 over 0.2 times 9.8. At the same time, this 10 over 9.8 meters. So you can see, it's very fun. Once you know what is all entails, you just be doing it in any way you prefer. Now we are told that there is coefficient of friction, which is 0.6. 0.6. So, which means that in addition to the component of the weight that comes down, we have frictional force added to it. And how does this one act? This is, if this is the body here now, G comes here, G sine theta. Let me make it in terms of energy. We have mg sine theta. At the same time, there is a normal to this surface from the component of the weight, and this one is G mg. Like this, comes down like this, mg cos theta. And this one you multiply it with the coefficient of friction. So we also have added to this, we have mg cos theta times mu. That is coefficient of friction. This one is for coefficient of friction. And you know that frictional field is not conservative. So you cannot use that one that I used in the other time. So this one you can easily do it strictly on the slant surface. You cannot consider throwing it up and that one. You can't. So now let's go ahead and finish it. Therefore, the using the law of conservation of energy, Ke at the base is equal to Pe at the top plus, sorry, I want to say P at the top plus work done against friction plus work against friction. So in essence, what I'm trying to say is, which will be equal to total work done against force. Total work done against force downwards. So, and this is the total force downward. Therefore, we have 4.5 half 4.5 times 2 squared will be equal to this one. We have to multiply this total force by S. 4.5 times 9.8. And what is our sine theta? 0.2 times 0.2. You get that one, times 0.2 plus 0.6 times 4.5 times 9.8. You can see times 9.8 cos theta, all multiplied by S. If I want to get the whole concept, this is the force overcome by the body in climbing up. Mg sin theta plus mg cos theta times coefficient of friction. That is the force, and this is what the force is. And this is total energy, and times S. That is what this one is, because you know that Fs is equal to the work done. Now let me work out the cosine. Cos theta is equal to 1 minus sine squared theta square root. You know from our trigonometry. And this will be 1 minus 0.2 square root. And let me get it out. And that is 0.998. 0.98. So that's, therefore, 9. You know this one is 9. 9 is equal to 4.5 times 0.2. Let me work it out. 4.5 into 0.2 times 9.8.2 times 9.8. 1.96 plus this one times this one times this. So I have 0.6 times 9.8 times 0.98. Now this one gives me 4.5 times 1.96 plus 5.76, 7.72 S. So S will be equal to 9 over 4.5 times 7.72. That is our S. And our S is going to be 0.2591 meters. Approximately 0.26 meters. So you can see, when friction comes to play, it reduces the motion drastically. So you can see, it's very simple and straightforward. If friction is not in it, you can use so many techniques conveniently, easily. When friction comes to play, it will not be easy. So also, you can also consider, just without thinking of the energy or whatever, just consider the acceleration and the velocity. The mass will be, that's the only thing that's made it different, the mass. If it is just the velocity and acceleration, you just consider that the total acceleration downward will be g sin theta plus g cos theta mu. That's all. Remove n. That's all. So v squared down will be equal to the acceleration I just mentioned up. So a here will be g sin theta plus mu g cos theta, and u is 2 meters per second here. But a here is minus. You can see. So with that, you can solve it without going into energy equation. So it depends on how you like it. But all the same, it comes to the same calculation. Now we have a question. It says, an hammer of mass 1.5 kg falls through a vertical height of 1 meter, and hits a nail of mass 50 grams directly without rebounding. If the nail is then driven into a piece of wood to a depth of 2 cm, what is the average resistance of the wood? Now let's have a pictorial view of what happened. This is an hammer here, and it weighs 4.5 kg, and falls through a distance of 1 meter to hit a nail into a wood. You understand? At this point, the velocity is 0. When it gets to the nail, it has a certain velocity. We call that one u. When it joins the nail of 4.5, they remove a certain velocity due to momentum, conservation of momentum. And then the wood will now resist the motion with certain force. And the force it will resist will include the weight of these two and that of the work that is done. That is the energy at this place. It is resisting it with the force. So there are two forces here that it will resist. It will resist the total weight of hammer and nail. At the same time, it is going to resist the force, is going to resist the energy here. So let us first of all look at it. The energy at this place, let's get it. We have from this height to this place. What will be we have u equals to 0. V here is what we are going to find. V equals to u, okay, v square equals to u square plus 2as. So we can use our g as positive in this instance. So v square is equal to 2 times 10 times 1. 2 times 10 times 1. So let's make our a equal to g, which is equal to 10 meters per second squared. Therefore, v square will be equal to 2 times 9.8, sorry, 9.8 times 1, because our u is 0. So v equals to square root of 19.6. And let's see what our v is. And that is 4.43 meters per second. After that, it will now join this and they move with common velocity because they said there is no rebound. So we now call that common velocity Vc. V subscript C, common velocity of nail and hammer. Then that will be equal to momentum before collision. Before collision is equal to momentum after. From law of conservation of momentum, please. From law of conservation of momentum. So we now have 4.5 times 4.43 plus 0.05 times 0, because that's the initial velocity of the nail, will now be equal to 4.55 Vc. So Vc, that is the common velocity of the nail and the hammer, will now be 4.5 times 4.43 over 4.55, and that is going to give me, so that gives me 4.381 meters per second. You can see 4.831 meters per second. And the easiest way to go about it is to calculate the energy at this point. The energy at this point, and then we will work it against the force that resisted it before it brought it to 0. So resisting force will be equal to F plus 4.55. And what do I mean by that? F will be the force that brought this energy to 0, that acted against this energy to 0. And this 4.55 is the weight of the hammer and the nail. Therefore, let me calculate F. F times, we are told the distance 2 centimeters, 2 over 100 will be equal to half ke, which is equal to half. So average resistance force you can see is going to overcome the weight of the hammer plus bring the hammer to rest due to its energy that has been driving the nail down. So it will be equal to force to bring hammer and nail to rest plus weight of hammer and nail. And what is that? It is going to be, let's first of all work out the force to bring the hammer to rest. Let that one be F. Force to bring hammer and nail to rest is equal to F. And our S in this instance, S equals to 2 over 100 meters. So Fs will be equal to the kinetic energy, the initial common kinetic energy of the nail and the hammer. So should be equal to Ke, which is half times 4.55 times, the common mass is 4.55 times Vc squared, 4.381 squared. So F is equal to, this is 2 over 100. 100 over 2 times half times 4.5 times 4.381 or squared. And what does that give us? Now, the force to stop the nail and hammer energy is 2,183 Newton. Therefore, R will be equal to F plus 4.55 G. And that gives me 2.183. Everything gives me 2,228 Newton, approximately 2,228 Newton. So you can see. So you have to consider it stage by stage, especially when you have resistive force or non-conservative forces involved. You have to take care stage by stage, because from here to here, once it hits this one, it will lose some energy, and then you start from there again. Else, if you say, oh, the energy here is going to be the energy at this place, you miss it. A particle of mass 2 kg is suspended at the end of a light string length 40 cm, which is fixed at its other end. The particle is held with string taut at an angle of 30 degrees to the downward vertical and let go. What is the maximum velocity in the ensuing pendulum motion? So what do we have? We have a situation like this. And we have this one to be 0.4 meter or 40 centimeter. And this angle here is 30 degrees. So we are now told that this body of mass 2 kg is allowed to go. So it will go down until it comes to this place. And here is where it's going to have maximum velocity. So we are now asked, what is the maximum velocity? So we are asked, so from here, so this is the 2 kg particle. So it is held like this, and then it is allowed to, it is released and it comes down. From here to here is our H, and this place relative to this place is going to have PE of mgh, and at this place the PE will be 0. It is relative to this place, and we are going to have Ke, which is equal to half mv squared. Now our work here is to find H. From here to here is 40 cos 30. Let me make it 0.4 cos 30. 0.4 cos 30. And from here to here, you can see it is the whole length string is 0.4. So H will be equal to 0.4 minus 0.4 cos 30 degrees. Therefore, PE is equal to 2 times 9.8 times 0.4 into 1 minus cos 30 degrees. This place, that is our h. And this one is equal to this one. Therefore, half times 2 times v squared is equal to 2 times 9.8 into 0.4 into 1 minus root 3 over 2. Now let's cut the quaternions. This one cancels this. Okay, let me do this. So this one cancels this. So v squared will be equal to 0.4 times 19.6 times 1 minus root 3 over 2. Times. So you can see, this is the velocity. I would have gotten it just by using our normal equation of motion. V squared equals to u squared plus 2as. And from there, the u is 0, and you get the same answer. A truck of mass 100 kg is traveling in a straight line on a level ground with a speed of 20 meters per second. After a distance of 30 meters, the ground slopes upward at an angle of 30 degrees to the horizontal. The frictional resistance of the ground is 5 Newton per kilogram. Find how far up the slope the truck will travel before coming to rest. If you want to consider it straight without breaking it, you have the body move like this and then slants like this. And this place is 30 degrees. And we are told that F frictional force is 5 per kg Newton. Oh, 5 Newton per kg. 5 Newton per kg. So, and here U is equal to 20 meters per second. Therefore, we have Ke of half mv squared here. Now, this kinetic energy, if you use part of it to overcome the frictional force on this distance, 30 meters, and that is, let's call that one WA. If you still use part of it to overcome this height, S, okay, let me make it here, S. Let's call that one WD. At the end of the day, it is going to have potential energy mgh. And you know that H will be equal to, let's call this place S. S sine 30 degrees. So let's look at what we are going to have. So our Ke here will be equal to work done A plus work done B plus potential energy. This kinetic energy is converted to the work here, converted to the work against friction here. At the end of the day, it came here. If I don't want to do it like this, I will just consider plus additional components of the weight down here, which is going to be mg sine theta. That will be the additional force. If I'm not considering it like this, I will show you how that one is. So here now I have half m times 20 squared. And what is my WA? You know I have 5 Newton per meter. So I have 5 times n, that is the force, times 30, that is the distance. In this place too, I have 5 times n times s. You can see. So, and here I have ngs sine 30 degrees. So, I'm going to have 150 n, you can see, plus 5 ns. Here n is the mass of the body. N equals mass of the truck. And then I will have plus ngs sine 30 degrees. Now let's cut what we can cut. Let's quickly cut n. Then let's look at what again. Let's divide 2 by half. I have here half. This one is half. 10. 300. So, and this one is 400. So, 400 equals to 300 plus 10s plus, and g is 9.8. 9.8s. Therefore, 100 is equal to 19.8s. So, s equals to 100 over 19.8, and that gives me that gives me 5.05 meters. That is 5.05 meters. Another way you can look at it is this. Calculate the kinetic energy at this point. Subtract this from this one. You get the kinetic energy at this place again. And this one is 5 m times 30 minus 200 m here. And that will give you 50 m here. 50 m. So from this one, it will climb 5 ms plus g sine theta. You can see the two work done with the 5 ms plus mg sine theta times s, because this is the component of the weight down. The component of the weight down. So this one will now be 50 m is equal to 5 ms plus, this one is 30 degrees, half mg s times 0.5. So from here you can calculate the s. This one was 400 and 200 m. This one is 200 m, and this one is 150 m. That's how I arrived at this one. So 50 m will now give you this. So 50. Let me say 50 is equal to 5 plus 4.9, because this one is 9.8 s. So s will be equal to 50 all over 9.9. And what does that give you? So it gives the same answer. So it depends on the way you want to do it. Anyhow, we will get back to the answer. But if you have been given the frictional coefficient, because this one is very small, that's why you do it like this. But if you have been given the coefficient of friction, this place, you have to do it mg cos theta times mu. That is times the coefficient of, so that one will be mg cos theta times mu. So please take note of that. We might come across situation like that later on. A cyclist is traveling at a steady speed of 4 meters per second. The total mass of the cyclist and machine is 80 kg. All resistance, wind, friction, etc. amounts to 1.2 Newton per kg per kilogram. At what rate is he working? We can get this by calculating the work and then calculate per second, or we use our normal derivative of mv. We have known the force. So total force, resistance force, is equal to 80 times 1.2, which is 96 Newton. And we realize that it is moving in 4 meters per second. So work done, if travel over s distance, will equal to 96 s Newton. So work done per second will be equal to work done over time to travel s distance, which will be equal to 96s over t, and that will be, and we know that s over t, that is 96 into s over t, since the speed is steady, is equal to 96 v watts. So power, so rates of work or power will be equal to 96 times 4 watts, which is equal to 4, 36, 384 Newton. So you could have done it straight and say W is equal to F times V. That is it, straight. And that will be 96 times 4. And you have 384 watts. So this is watts. 384 watts. A train of mass 200 tons is traveling on a level track at a steady speed of 500 kilometers per hour and working at 75 kilowatts. What is the resistance per ton to motion? That's one. Two, if the engine continues working at the same rate and the resistance is unchanged, what is the maximum speed with which it can climb a slope of 1/400? Three, if it travels at the same slope, up the same slope at 20 kilometers per hour, what acceleration will it have? Now let's start by looking at it from this perspective. We are told that the mass is 200 tons and the speed 50 kilometers per hour. So let's convert to meters per second. That is going to be 50 times 10 over 36. 500 over 36 meters per second. Then we are now asked, what is the resistance per ton? We have realized that what is equal to FV. And from this place, we see that our watts power is equal to 75 times 10 raised to the power 3. Now, what is our F? Our F will be equal to unknown, yes. So that's what we are looking for. Therefore, work is equal to FV. 75 times 10 raised to the power 3 is equal to 75 times 10 raised to the power 3 is equal to F times 500 over 36. But so our F is equal to 75 times 10 raised to the power 3 times 36 over 500. So that is again 75 times 2 times 36 Newton. But we know something, that what we are asked to find now is force resistance per ton. Therefore, resistance per ton will be equal to F over 200, which is equal to 75 times 2 times 36 over 200. So, the total force resisted is 5,400 Newton, and the resistance per ton is equal to 27 Newton. That is 27 Newton per ton. Now let's check the second one. It's asking if the engine continues working at the same rate, that is, the rate is still the same, and the resistance is unchanged, what is the maximum speed with which it can climb a slope of 1/400? So you are going to have additional force of that and this, of this one and this one, because this loop is going to add to the resisting force. Let's see how it works. Now this train now wants to move over a place. Here the slope is equals 1/400, and it's very small, so we can take this to be approximately our sine theta. Approximately our sine theta is very small, you can see. Now already we have a resistance that we know. Initial resistance without friction. Resistance without friction. Resistance without slope. Resistance without slope is equal to 5,400 Newton. Now, the slope will add to the force now. Now, let's do the second one. We have known that the total resistance on level ground without climbing will be equal to 5,400 Newton. Now, this is it. The body is moving up like this. So, the total resistance now will be this 5,400. This weight will have additional whatever resistance due to its component downward, and that will be ng sine theta. We are told that slope is equal to 1 over 400. So we can take this as our sine theta. So sine theta is 1 over 400. Therefore, total resistance on climbing will be equal to 5,400 plus 200, okay, 200 times 10 raised to the power 3 times 9.8 times 1 over 400. So we can add this 2, and this one is 500. So total resistance against motion is going to be 5400 plus 4900, which is 10,300 Newton. And since the power remains the same, 75 times 10 raised to the power 3 is equal to FV, which is equal to 10,300 V. So the new velocity we have, maximum velocity now, will be 10.75 over 10. So this is what I have, 75. So that's giving me 7.282 meters per second. 7.282 meters per second. And if you convert it, it will give you 26.21 kilometers per hour. So if you convert it back to kilometers per hour, that's what it gives us. The third one now. Now, we are told if it travels all the same slope at 20 kilometers per hour, what acceleration will it have? In this instance, our total force will differ now because the velocity has changed. So if V in this instance is equal to 20 kilometers per hour, which is equal to 20 times 10 over 36 meters per second. So the F, the force generated now, will be equal to F, and F V will be equal to power. Therefore, this F times 200 over 36 will be equal to 75 times 10 raised to the power 3. So F will be equal to 75 over times 36 over 200. So our F generated now, the force generated now will be equal to 75 13,500 Newton. So the force generated now will be 13,500 Newton. But force is greater than all the resisting force. Please, you can see that the force generated now is greater than the total resisting force. So the net force will be equal to 13,500 minus 10,300. And this one is going to give us 3,200 Newton. 3,200 Newton. So A, acceleration will be equal to net force over mass, which is equal to 3,200 over 200 tons. Is 16 over 1,000, which is equal to 0.016 meters per second squared. So you can see, you just need to take it in tons and you arrive at your answer.